Hi there. So in this video, I'm going to be taking this paper, IAL P1, May 2024. I have never seen it. I have never done it before. I'll be timing myself for 1 hour and 30 minutes. I'll also tell you my thought process, what comes into my mind, and how I approach each question. And I'll mark the paper after I'm finished. Once I hit the timer, there'll be no cuts and no edits. And I sure hope that this is going to be useful for you guys. Let's get started. I'm going to start the timer now. And I'm going to be writing on the right part of the screen here, guys. All right. So question 1, we have to find the integral of that. So I'm just going to write integral of that. Just going to repeat the question here, guys. Okay. So 1 over 2 x cubed plus 3 over square root x minus 4 dx. So it is simpler to just change all the terms in the form of index. So for this one, we're going to change it to that. And for the second term here, this is x to the minus half. And for the last term, no change. And then the real integration happens here. Because there's no bounds here. Oops. This should be number 2. So integration of a polynomial term is just adding the power by 1 and bringing that added power down to divide the term. So this is x to the 4 divided by 4, and we don't forget that we already have a half here multiplied. The next term, x to the power of, well, you have minus a half. If you add 1, you get a half, right? And then you divide it by a half here and multiply it by 3. And then minus 4, we just add 1x in, and that's it. But never forget plus c, all right? Some paper allows, some paper doesn't allow, right? So simplifying all the terms, we get the first term, the 2 and the 4 here can multiply. We get 8 there, plus, so denominator in the denominator of a fraction like this, we can just pull 2 up to multiply with 3. So we get 6 here, and x to the minus, to the half. And then minus 4x is just there, and then, so this is going to be my answer to the first question. Okay, so second question. All right, so what do we have here? We have A. So for that inequality, well, inequality. So it seems like I should expand them first. So I'm just going to expand 5 into the brackets. I have 5x plus 15 greater than 4 expanding in. I get 8x minus 20. So that would be my first line. And then looks like if I move if I minus 8x on both sides, I get minus 3x on the left. And if I minus 15 on both sides, I get minus 35 on the right. And we can make x the subject by dividing into by dividing by minus 3 in both sides. So I'm going to get x here. But when you divide by a negative number, the sign should flip. That means instead of greater than, we have a less than. And that would just be 35 over 3, right? Now note that I already canceled the minus sign. So there are 2 minus signs here on the right side. So that's just the answer there. That's done for A. And now for B, right? We have question I. Write that in the form of a complete square, basically. So a complete square, so the first step, I would probably think about the last term here that would make a perfect square. Well, the easiest way to do that, this is a trick, right? So it's just dividing this term by 2. So I get minus 3. But then you square that term. So minus 3 squared, you get plus 9. But because we can't just add a number from this given quadratic without compensating it back. So I'm just going to compensate that outside the brackets here I just made up. So I just add a minus 9 there to make it the same, and don't forget a plus 1 here. So if you're not happy with this, try work backwards here. If you try work out, expand all out, and simplify, you're going to get the same thing as the question, right? But the complete square is going to be, it's going to come after we have looked at the brackets here. So x squared minus 6x. Well, that is simply if you take the second term here, minus 6 divided by 2, you're going to get minus 3. And that would just be, you know, magically, that is just the complete square form for the brackets. And then if you simplify it outside the brackets, you have minus 8. So that would just be the answer there. All right. And number 2, II, hence solve for that. So because it seems like this is the same quadratic, so I'm just going to bring the complete square form down here, and then says that it is greater than 0, greater or equal 0. We're going to solve for this, right? So it says hence, right? So we're going to use this. The easiest way to solve and using the complete square is to just isolate x, right? Or actually using like difference of squares. Sorry, it's difference of squares. We're going to factorize this. Again, if I bring a squared minus b squared equals a plus b times a minus b, we can look at these two terms as this one being the a squared and this one being the b squared. So in this case, a is actually x minus 3 and b is actually square root 8 because we need to make b squared there. So b squared is totally 8, but then just for b, it would be just square root 8. So I would write, so on the left part here, I would have x minus 3 being just the a plus square root 8. That is just the first brackets. And then second one, a minus b. So I would have x minus 3 minus root 8. Yeah. And I'll put that greater than 0. Okay. So this is already solved. So we can say that the roots, if this was an equation, the roots would be just the critical values. And by critical values, I mean if you put each of the brackets here equals 0. So you have x minus 3 plus root 8 equals 0. So x will be the x value from here will be one of your roots. So it would be 3 minus root 8. And the other one, right? So x minus 3 minus root 8 equals 0. So this is going to be your other root, which is 3 plus root 8. Yeah. And root 8 is also 2 root 2, right? For your reference. So because this one is greater than the other one, and because this is a greater than or equal sign. So if I draw the quadratic quickly, right? This quadratic is a normal quadratic curve, a normal parabola. So it's going to look like, so this seems to be a positive value there. No, it's not. It's a negative. So it's about something like this, right? So we want the part where the curve is above the x-axis here. Being greater than 0 means it's above the x-axis. So it's going to be this part to the left and this part to the right. And these intercepts are just these two roots, right? So we can say that the solution would be, x greater than, less than first, less than the smaller one, 3 minus root 8 with the equal sign. Or, let me move that a bit to the right. No, probably I'm not going to move that. Or x greater than 3 plus root 8. Yeah? Yeah, so we go to the right and go to the left of either root to cover the inequality solution. All right? So far so good, right? So we have done the second part there. Now C. Hence find the values of x that satisfy both the first and the second part, basically. So the one is from question A and the second one is from question BII. So from A, what do we have? We have x less than 35 over 3. Let's double check that actually. So I have 8x minus 20. So move there, move there. Yeah, everything is fine. So 35 over 3. If we kind of draw a number line, we have 3 root 8. So this is about, root 8 is about, almost about 3. So that's about 9. So I'm just going to put it here. And yeah, actually, let's just put root 8 in there. So it's about 2.8. Yeah. Well, actually, it wasn't negative, right? So this is still a positive, but anyway. So let's say 0 is here. This is 3 minus root 8. Yeah, almost 0 there, about 0.2. And then you have another one. Where was that? 35 over 3. That was about 10-ish. So 10-ish should be to the right of that number, even further to the right. So that is 35 over 3. Okay. So from part A, we have this thing. So an unfilled circle means that you cannot take this value. This is from A. And from B, we have less than that value where it's a filled circle. And also greater than that value where it's also a filled circle because it can take that value. Now, if we look at the question, there is a word and. So we got to take both conditions must satisfy, right? So it's the intersection of this area here up to that, and also all the way there to the left, still going to the left there. So the intersected answer would be, here would be x less than or equal 3 minus root 8, or x, so it's going to take that value as well. Let's do a range here. We have a lower bound here and upper bound here. So this is less than 3 plus root 8 with an equal sign. And because the answer from A doesn't include 35 over 3, so it's got to be less than 35 over 3. And that would be my answer to C. Now, let's get to the next one, question 3, right? So question 3, y equals x cubed plus 96 root x plus 5, where x greater than 0. Find dy by dx. Derivative, that is. Giving each term in the simplest form. All right. So we can change the question to, we can change y to the index form first again. X cubed plus 96, x to the half plus 5. So when we differentiate, we're going to get, so differentiate bringing 3 down and power subtracted by 1. So we get 3x to the 2 half there for the first term, and plus, again, this is 1 over 2 bringing down 96 times 1 over 2. I'm just going to times 1 over 2 already, so I'm getting 48, right? Just by a mental math. And then x to the power reducing by 1, so we get a minus a half there. And differentiating a number gives you 0. So that's it, right? This is already a simplified term. Okay, so that's done. And then part B, find the solution of the equation. Okay, so we got to differentiate that again, yeah? So d squared y by dx squared, because this is called the second derivative. So we're going to have to differentiate the first derivative, which is up here, what we just did. Again, differentiating that, bringing 2 down, multiply with 3, we get 6, and power reducing by 1, we get just x. Bringing the power down again. Now this time there is a minus sign, so I'm changing this to a minus. A half multiply 48, I get 24. And the power reducing by 1 more. So that would be minus 3 over 2. And that would be it. Now, we got to equate this to 0, right? And find the solution. So we equate that to 0, and then find the solution. So I would just, in the first step, maybe change everything here. Well, actually, let's factorize, right? So I'm going to factorize x to the minus 3 over 2 out. And then inside, and also 6 as well. So 6x to the minus 3 over 2. So the first term here, 6 goes away, but I'm going to have to think of what to put here as a power of x, so that when you multiply the x to the minus 3 over 2 back in, you get 1. And that has to be something like 5 over 2, right? Because when you multiply them back in the brackets, when you expand that, you're going to get the powers adding up. So you get 2 over 2, so that becomes 1, right? That's the way I do it, basically. So why do I take this? Well, because if you look at the other term, it's easier. I get 4 here, right? And the power is already the same as that. So just 4 equals 0. And now you can see that we can, split into two brackets here, but looking at the question, writing the answer, that's a singular verb. So there won't be multiple answers. That means I think we can't put 0 to this because we can't divide by 0 from this term. So that's not going to be possible. That means we are only relying on this one, equals 0, right? So x to the 5 over 2 equal 4. And because you're doing P1, so for those of you who haven't done P2 or logs, the easiest way to solve for x here is to think of the way to power both sides, that when you use the index property, this one, a to the power of m and then to the power of n again, you multiply the power together, right? So we're gonna power by something on both sides so that the powers cancel on the left side, and then you are left with x. And that would be 2 over 5, right? Because when you power by 2 over 5 on the left side, you get x to the 1 there. Yeah, because they cancel, just fraction of reciprocal there. But we got to do that for the right side as well. So x is 4 to the 2 over 5. Now 4 is basically 2 to the 2, right? So 2 to the 2 and then to the power of 2 over 5 again. Yeah, so we want the answer in the form of 2 to the something. So that is already done, 2 to the 4 over 5. Okay, so that would be the answer there. Okay, so this is question 3 done. Next, question 4. The time looks good, guys. Question 4. The curve C has equation y equals blah, blah, blah. The straight line L has equation that, where k is a constant. Show that L meets C when. Okay, so L meets C. Meeting mean, so whenever there's any two graphs meet or intersect, we can solve simultaneously, or we equate the y, right? So here they already have y as a subject for both equations. So I'm going to just say something like y of C equals y of the line, basically. So 2 over x plus 3x minus 4 would be equal to kx plus 2. Okay. So we're going to somehow show what they want there, but it seems like they don't have something over x here. So when you look at this form, the way I would take it forward is to maybe get rid of the denominator x there, and we can do that by multiplying by x across the equation, multiplying out. So multiplying x to all the terms, we get 2 here for the first term. We get 3x squared. We get 4x. And on the right side, we have kx squared plus 2x. Yeah, basically multiplying x every term. And then seems like we have to collect the terms. So seems like we have k minus 3 here. So I got to move everything to the right instead. Okay, so my 3x squared, if you subtract that on both sides, you're going to get minus 3 here. And factorizing out the x squared, I already have that. The 4x here, adding them on both sides, adding 4x on both sides, I get 6x on both on the right side, sorry. And then the 2 here move on the right side, I get a minus 2. So that is already kind of what they want, right? Unless if I need to write again properly, right? So that is also fine. And that is part A, right? As required. Hence, find the value of k for which L is a tangent to C. So the value of k for which L is a tangent to C, well, being a tangent means about the gradient, right? So because y of curve C, again, is that, yeah, gotta write it down. So we know that the gradient of the tangent can be found by using the derivative function. So we got to do dy by dx here, right? So this is, again, okay, let me write that again. So 2 to the x minus 1, sorry, 2 times x to the minus 1 plus 3x minus 4. We need to differentiate this curve function. So the first term will give us the power bringing down, we get -2, and the power subtracted by 1, we get -2 there. 3x would become 3, right? Just the x would cancel out when we differentiate. It's like it goes away. Okay, now L is the tangent to C. So M of the line L, right? When L is the tangent to C, it means that the gradient of the tangent L is going to be the same as the point where we are finding here. So it's like we are equating the gradient of this L to the derivative function so that we know, right, the point, that point on the curve with the same gradient ML here. And because if you look at the equation of line L, actually we don't know the gradient. Actually it is K. And actually it asks you to find K. So M of L is equal to K. And we need to equate this K gradient to the derivative function of the curve because it's tangent to the curve. So I'm just going to say that. Okay, basically this is part B. And now we want to find the value of K here. So, right. Okay, let's see. So the gradient is K and, and there's another point because they do meet, right? Now, okay, so being a tangent, right? I'm just going to write here at, say, at some point, at point P, okay, let's say, it means that they both touch, right? So this is the intercept already between the 2 points. And that means we can use this equation, right? Because this is the point where they also intersect. And this is also true. So it's like, we know that K is equal to that due to the tangent being, having the same gradient as the line L. And we also know that they intersect, right? So it means that we solve these two equations. All right, so we're going to solve simultaneously. Okay, so I'm just going to maybe substitute, yeah, just going to substitute this whole thing into the x, right? Hang on, do I do that? No, maybe not. Let me think a bit. Okay. I just saw something actually. So if I move 3 to the left here, what do I get? Yeah, let me use the same color. So if I move 3 to the left here, subtracting K, I get that. Right? And I happen to just notice that K minus 3 can go there, right? So, but instead it is this guy. Now, why do I need to do this? Because when I do this, K goes away and I can solve for X. And after I have solved for X, I'm going to solve for K. It might be a little bit of a detour, but I think it's simpler this way because if you try the other way, you try to get rid of X, it is more complicated to solve for K directly. So I'm going to solve for X first. So subs. Here I get, in the brackets of K minus 3 that, I get this multiplied with that and plus 6x minus 2 equals 0. So you see, guys, I just happen to see that this can also cancel because it's x to the minus 2 plus 2 becomes 0. And what you have here is just minus 2 plus 6x minus 2 equals 0. So it would be equal to minus 2 is 4, minus 4, I move to the right, divide by 6. So that would be my answer. And it's just one value from the question. So if we want the value of K, then we can just maybe using that, okay? So K equals minus 2, x to the minus 2 plus 3. And substituting the x value we just found, we get that. Oops, I forgot to do that. And then, so this is basically flipping the fraction because it's a minus power. So you can also put it in a calculator, but I'm just going to go find the exact value here. So it's like flipping the power and the power becomes positive. So that would be 9/4 right there for the fraction and power. And 9/4, if you multiply with minus 2, you would get minus 9/2. Yeah. just canceling there, and plus 3. So this will give you, so 2 times 3 is 6, so minus 3 over 2 as my final answer. All right, calculator will help, guys, but I just don't like using it. Yeah, all right. Number 5, so far so good. Fully factorize these, whatever, yeah. Okay, so I can see right now that I can pull x out of everything because there is one x in every term at least. So I'm just going to do that first. I'm getting 9x squared minus 10x and then plus 1. Yeah, I'm being thorough. And then I'm trying to factorize this, but you guys can use a calculator. Solving using the equation and function and then manipulating the root somehow, but I'm just gonna use my brain. So let me try maybe use, yeah, I can try 1 and 9 actually. So if I try 1 and 9, it should work. Yeah, so I get that, right? Let me check. Yeah, it works. So that's it. That's my answer, right? And that is A, so that's B. Hence solve for that. All right, so we got to be careful here. We got to compare the term. It looks like we're going to have to put x as being, so we let x as being 3 to the y. Okay, so if we check, x to the 2 would be 9 to the y. Yeah, x to the 2 would be 3 to the y to the 2, and it's actually 3 to the 2y, but you can write 3 to the 2 and then to the y like that, and you get 9 to the y. It's a bit subtle, but if you use the laws of indices, then you're going to get there. And it's also true for 27 to the 9, right? If we try inspect that. So when we have this, yeah, then we can go ahead and solve the cubic here. And once we get the solutions for x, we can compare that to the solution for y, like the 3 to the y here comparing to x, right? So solution to x would be x equals 0, x equals 1 over 9, and x equals 1, right? But then this will have to be equal to 3 to the y, each of them. So let's analyze one by one, just to be careful. Is that possible, right? 3 to the something gives you 0. That is not possible for exponential, right? It's not possible, so this is no solution. Okay, no solution for that. I'm just going to delete this out first. And then this one, 3 to the y equals, well, 1 over 9 is 3 to the minus 2. You can try check that in the calculator, but when you see 9, well, you got to recognize that 9 is 3 to the 2, but this is a fraction, it's a reciprocal, so the power becomes a minus 2 instead. Well, that means y equals minus 2 for this case, right? Yeah. And 3 to the y equals 1. Well, you got to realize quickly that anything to the power of 0 except 0 is going to be equal to 1. So I will have to put y as 0 there, and there is no solution for this. So these are just the solution. Y equals minus 2 and y equals 0. So question 6. Next. Okay. So question 6 is about this. Hang on, let me expand a little bit, yeah, so that I see the marks here. Figure 1 shows a sketch of the entrance to a tunnel. Yeah, the shape of the entrance consists of a sector BCDF. BCDF. So that's a sector of a circle, center F, joined to two congruent brackets, identical triangles. All right, thank you. ABF and EDF. All right. Given that AEF is a straight line, okay, blah, blah, blah. AF equals FE. And FB equals FD, so these are radii. Angle BFD is just that. Okay. Show that the angle AFB is 0.433 radians to 3 decimal places. Okay. I'm probably gonna need to maybe take the image here. Let me just try and do that. Okay, yeah, because I'm gonna need to annotate on that. Okay, I've got the figure here, guys. All right. So we need to find this angle. Okay. And we already know that BF is, sorry, no. Yeah, FB. Yeah, 6.2. And this is also 6.2. This is AF is 6.4. Okay. Yeah. So these two angles must be the same. So if we know this angle, we can find the other two because AFE is a straight line. So that means we know this angle. We must know these angles sum up. Like they should sum up to be the remaining, and we can find each one of them, right? Okay. So yeah, we already know that this is 2.275 radians. Okay, so we can do pi, which is just the angle on a straight line there, pi minus 2.275 will give you 2 of the theta. And then we divide that by 1, we would get just 1 theta. Yeah. So I'm going to just put in a calculator here. Yeah. So fraction pi minus 2.275 divided by 2. So yeah, I do get that. 0.433 blah, blah, blah. And then we round it to 3 decimal places. There you go, as required. Find the perimeter of the entrance to the tunnel. So basically, it's just perimeter of everything. Yeah. Wait, the entrance consists of a bisector BCDF, BCDF of a circle center F, drawn with 2 congruent. Okay, yeah, it says A, B, C, D, A, B, C, D, E, F, A. So basically the outer perimeter. I was just thinking that, I was just wondering about the lines, the other lines inside the shape, but yeah, it's just outside. Okay, so yeah, we need to find AB, and that would be equal to DE. We know AF already, and we can find the arc, right? So this part here, AB. So how are we going to find AB, right? We already know the theta here. Well, we have a triangle here, and we know the angle between the two known sides. That should be a cosine rule, right? So cosine rule, I'm going to have AB squared, yeah, equals 6.4 squared plus 6.2 squared minus 2, the product of the two sides, and cosine of that angle, which I'll take, well, I'll just write theta. But actually, I'm going to take this in the calculator, yeah? Okay, so AB would be equal to all that. Well, here I'm just going to write the actual value, but I'm going to do that, dot, dot, dot. So put that in the calculator and square root. What am I going to get? So square root of 6.4 squared plus 6.2 squared, and then minus 2 times 6.4 times 6.2. Am I getting it right? Yeah. Okay. And then multiply, now it has to be in radian there, cosine 0.433296, just to be thorough here. So that should give me 2.7. That seems to be a reasonable length. I'm not getting something too weird. So that is just 2.71549 dot, dot, dot. And I'm going to have to round it to 1 decimal places. So I'm just going to keep it like this first. So we have A, B, and D, E already, and AF is just that. So let's do arc BCD, yeah? arc BCD. So arc BCD is going to be equal to, the formula is just S equals R theta. So arc length being X, S. And then R is the radius. So radius is just basically BF or FB, which is 6.2. So 6.2 times theta, which is given to be 2.275. Okay, so 6.2 times 2.275. We have, let me check again. Yeah, 14.105. All right. Now, perimeter, everything equals 2 of the AB. So 2 of that plus 1 of the arc, big arc, and plus 2 of the straight lines here, AF, which is 6.4. So that would be the perimeter, guys. Okay. So I already have that. So I'm going to do that plus 2 times brackets 2.7154. Then add another 19 just to be safe. And plus 2 times 6.4. Yeah. See if I put everything right there. Yeah, I think so. All right. Wait, where's 2? Yeah, okay. That should be fine. Okay, yeah, I think just checking. 32.3 as 1 decimal place. Okay, so that is the perimeter. And question C, we got to find the area, cross-sectional area of the entrance. So A, B, C, D, E, F, A. So everything basically. So that's going to be 2 of the triangles plus the sector. 2 of the triangles is, so we can use the formula half AB sine theta because we know the 2 sides and the angle between the sides. So it's 2 of the half. A is 6.4, B is 6.2 sine theta. So sine of that theta we just found, which is all that. Plus the sector area. So the sector area, we can use the formula half times R, sorry, half times theta R squared. Yeah. And theta being 2.275. And then R squared, R is 6.2. And I'm going to put all that into my calculator. Okay, so 1/2 cancel. So it's 6.4 times 6.2. And then sine of, where's my sine? Sine of 0.433296. So that would be the area of just the 2 triangles. And then, oops. Yeah. And then plus 1/2 times 2.275 times 6.2 squared. Okay, so that is 60.1 decimal place. We get 60.4 actually. Yeah, so let's check everything again. 6.4, 6.2 sine of that angle being the theta angle that we found in the first question. Everything is fine, I hope. Then half times that squared, because that is the theta, that is the sector area. And we get that answer. So that's done. Next one is number 7. Oh, it's just 38 minutes. Yeah, we're fine. Okay, looks like this is coordinate geometry. A, find the distance AB. Writing your answer as a fully simplified surd. Okay. Straight line L shown in figure 2 as equation that's straight line L1. And point AB lies on L1. Point A lies on the y-axis. Okay. Point B as x coordinate of 10. Okay, so we already kind of can work out A already because, yeah, we will know A and B. And because this is, wait, it doesn't say rectangle, does it? So we don't know for sure. But anyway, find the distance AB. All right, that's fine. So because we have this equation, 5y equals 2x plus 10. Now, because we know that A is on the y-axis, meaning that it is a y-intercept, and we can put x to 0 to find where y is, okay? So that's going to be 5y equals 10 because 2x goes away, so y equals 2. So that means A is 0, 2, right? And what about B? So B has the x coordinate of 10. So if we put x coordinate of 10 in there, we're going to get that. So y is just 20 plus 10, 30. 30 divided by 5 is 6. Okay. So B coordinate will be 10 and 6 because x is 10 is given. Okay. Y is just found there to be 6. And then we find the distance. So distance AB, yeah, is going to be equal to, well, we can do the formula there, which is kind of like a Pythagoras formula there. So delta x squared, so delta x 0 and 10 squared plus delta y 2 and 6 squared. So that would be 100 plus what? This is 16, right? Yeah, they asked you to do the simplified surd. So that's going to be 116. So what can we do? We can pull 2 out, or we can put 4 out. If we do 4, that's going to be 8. Okay, yeah, we can put 4 out. So 4 is a factor there. 4 times 29. Yeah, I think 4, 2, yeah, 8. And then, yeah. So that will be 2 root 29. Yeah, because 4 is a square number. We can take the square root out like that. Yeah. So that is going to be my distance AB. Fully simplified surd, of course. Question B. The straight line L2, also shown in figure 2, passes through B perpendicular to L1. Good. All right. Find equation of L2. So it's perpendicular. That means the gradient. Okay, we find the gradient of L1 first. The gradient of L1 would be, if you divide the equation of L1 here by 5, because this is given, 2 over 5 here would become the gradient of L1. So we can say that gradient of L1 is 2 over 5. That means the gradient of L2 would be minus 5 over 2. Just again, flip the fraction and put a minus sign. Okay. So, and then we can use the formula y minus y1 equals mx minus x1. That's the very commonly used formula. Okay. Wait, I think I need to add a page first. Yeah, let me add a page first. I thought I wouldn't be using these many pages, but anyway. And let me just, I'm going to be quick, guys. Sorry. Just wait a bit. I have to delete here, and then I'm going to duplicate all the pages for the future use. So let's copy that page and make plenty of pages so that I don't have to do that again. Yeah, well, that's too many now. Okay. All right, go back to that question. So we're going to have to find the equation of the line. So yeah, x1 and y1 would be the point that the line passes. In this case, I would take it as B. So B is already 10, 6. So 10, 6 here. So I'm going to do y minus y1, which is 6. M is minus 5 over 2. X keep the same, minus x1 being 10. So the easiest way I would go here is to get rid of any denominator first. So I'm going to multiply it by 2 then. Every term again. So 2y minus 12 equals getting rid of 2 and then multiplying minus 5 into the brackets, I get minus 5x, and then minus 5 multiply minus, then I get plus 50. Got to be careful with the signs. And then I got to move every term to the left side, so I have 5x plus 2y. 50 subtract from minus 12, we get minus 62 equals 0, right? So that is kind of like done. Okay, so that's done. Right. Yeah. So see now, line L crosses the x-axis at point 4, sorry, at point C. Okay, line L2. Point D is such that point A, B, C form vertices of a rectangle. I knew that. Shown shaded in figure 2. Find the area of the rectangle. All right. So rectangle means that we can use the width times the height of the rectangle. Yeah. So because we already got the length of AB, that's good. We only need to find BC, right? If we find BC, then we're done. We just multiply AB and BC. So how do we find BC? We need to know point C first, I guess, because point C is an unknown for now, is the x-intercept and will be known shortly. So point C, x-intercept of line L2, we just got L2 from here. So we're going to put y equals 0 in L2, all right? So that's going to be at 0 there, minus 62 equals 0, okay? And so for x, so x at point C would be 62 over 5. I'm going to keep a fraction here, guys, okay? And then, yeah, so point C would be 62 over 5, and then coordinate 0 here for the y, because that's where point C is. And then if we find the BC, we can use the Pythagoras again. Yeah. Again, B is what? B is the same point, 10, 6. So it's 10 minus the x coordinate of the C squared plus 6. And minus 0 is just 6. So I'm just going to do that. Yeah. Yeah, it doesn't say exact, so I can just use a calculator here, this one. See if I get any nice number. So brackets 10 minus 62 over 5 down there. And then in the brackets, oh no. Brackets, I square this brackets, and then plus 6 to the 2. Ooh, that's, yeah, a horrible number, but we're going to take it because we don't need to do exact. So that's 6.4621 77977 blah blah blah, whatever. And then we're gonna do area of rectangle would be equal to AB times BC, which is AB being a third to root 29 times 6.4621 blah blah blah. I'm just gonna multiply what I got from a calculator, sorry, by 2 root 29. Yeah, that's it. Oh, the answer seems to be just that, amazingly. Well, okay, that's nice. All right, so I think we're done here. Then number 8, right? The time is still good. The curve C with equation that passes through point R, given that use integration to find fx. Okay, so it gives you the derivative of fx. In order to find fx, you need to integrate. Yeah, so fx is just going to be integral of f dash x dx. So we integrate it first, but probably the easiest way is to expand them first. So if you expand the two brackets, the number 2 here, I don't like it in the integrand, so I take 2 out. But then the two brackets expanded, I can do 3x squared. I'm just going to do it already here. Now, the middle, and so minus 3 and 3, you get minus 9x. But then you also get x multiplied with 2, so that's another 2x there. Minus 9 and 2x together is minus 7x, yeah? Minus 3 and the 2, you get minus 6. All right. Yeah, I think I'm okay with that. And then integrate all that, right? So we're gonna have to carry the c this time because we don't have the bounds. So that's gonna be so integration, we add the power and divide. So this is x to the 3, adding 1 already, divide by 3. So that will cancel the 3 in front. But this will be x to the 2 over 2. Yeah, this will be 6x. And that, and then plus c outside, because I don't want to keep it inside. So you would have 2x to the 3 minus 7x to the 2 minus 12x plus c. So that is the fx, a general solution because we don't know c yet. But now we do know that the fx passes through point R. So we can use point R right there, substitute it in. So y being fx, and then 2, 4 to the 3, minus 7, 4 to the 2, minus 12x, plus c. And then we can find c, right, from that. So using a calculator, maybe it's too much now for my brain. So my 13 minus 2 times 4 to the 3 minus 7 times 4 to the 2. Sorry, it should be plus because I move on the other side. Yeah. Yeah, plus 7 times 4 to the 2. And then a plus 48 because 12 times 4 is 48. So I get C as 45. Let me check that again. 13 minus 2 times 4 to the 3 plus and plus. All right. Yeah. So this is the equation. Therefore, fx is all that with C now solved. All right. There you go. Okay. B. Well, this is A, right? Yeah. Given that fx can be written in the form blah, blah, blah. Okay, so seems like we need to factorize, but there is a big hint. Yeah, so you already have a quadratic factor here, x minus 3 squared. So probably we need to do, or we don't. Actually, we don't, right? People might think that they need to do a long division, but let me show you why I wouldn't do that in this case, because if I expand the x minus 3 to the 2, I get x squared minus 6x plus 9. And because they already have a p and a q in place here, well, it's like, I gotta be careful when I write numbers, right? So this is 9, this is my q, yeah? So it means that if you multiply 9 and q, you're gonna get the last term, right? That's the only way you get the last term. So 9 times q, that's 9q, right? 9 times q equals 45. That means q is going to be equal to 5. That's easy, right? And how do we find p? Well, maybe we can look at the x term. Yeah. So the x term, there is 1 here from the q, so minus 6qx. Yeah. And another one here, pqx, right? It's going to have to be equal to the x term that we got from the fx. So that is going to be minus 12x. And of course, we can cancel the x out, right? Because we are comparing the term here. And we also already know that q is 5. So q 5 multiplying 6, I get minus 30 there. So this is just 5p equals minus 12, right? Solving for p, moving 30 on the other side, I get 18, and dividing by 5 would give me p there. All right, so that is P and Q solved. Okay. Question C. Sketch the graph of y equals f2x, showing the coordinates of any points where the curve touches or crosses the coordinates axis. So guys, if we were to plot just the fx first, we can use the factorized form. So let's have a look at the factorized form first. So fx We already have that in place, and P and Q. So P is 18 over 5. X plus Q is 5, right? So that is the equation for Fx. Now, if we actually do plot the Fx in our curve here, in our graph, this is a repeated root. So you're going to have like a turning point on that root. So that root being 3 here. And the other one, if we equate this to 0, what do we get? So it's going to be x equals minus 25 over 18, right? It's on the other side of the x-axis. Yeah. So minus 25 over 18 is about a bit more than 1. Okay. So you're going to have the curve something. So it's going to be a positive cubic, right? But we got to have the turning point here touching the 3. Yeah. So it's going to be like that. Of course. Now, but because we have f2x, and that means the x-axis will be sort of compressed by 2 times because x is doing the opposite sense in transformation. If you have a multiply 2 in the brackets, you gotta divide by 2 in your actual graph. So I would just do like this. So I'm just gonna shrink this down to 1.5, right? Or 3 over 2 better, right? And this is going to be also divide by 2. So I'm going to get 36 instead. That is just multiplying the denominator. But what about the y-intercept, right? The y-intercept doesn't change. So I should get the same point, which would have been the same if we substitute x to 0 there. We're going to get the same point. Do we need to put it there? Yeah, crosses the coordinate axes. So if we put x to 0 for the fx, yeah, so that would be, so f 0 would be equal to 9 times 5, which is 45, right? Yeah, so this is 45. And I think I'm done with that curve. Good, good. So that's number 8 done. And number 9, I think, is it the last question? Not yet. We have 10 questions to go. All right. That's a bit tough. So what do we do here? This is trick, guys. Okay, so A state the number of solutions of the equation. So we have 10x minus pi over 6 equals pi minus x. That is like looking at the line L with the equation pi minus x. How does it intersect? How many points it intersects with the 10x minus pi over 6? And they already drew it here. Okay. So we got to know where the 2 pi is. Let me also again just screenshot that and take it to this screen so we can analyze it better. Okay, so because this is a transformation of the normal tan, and if you think about the normal tan, you have actually the middle part here being from minus pi over 2 to pi over 2, yeah? And then you have another period here of the tan, like that. And you're going to add pi from pi over 2. So this point is going to be 3 pi over 2. And then add 2 pi is going to be that, right? So it's just, it got cut off at that point. Now, when you shift this whole thing, these x-intercepts will be moved to the right, right? Everything will be moved to the right. So pi over 2 will be instead added by pi over 6 and so on for 3 pi over 2 and 2 pi. Yeah. So it occurs that, yeah, so if you imagine you are moving all the 3 lines to the right, but you keep the same domain. It's 0 to 2 pi. So like, for example, imagine, okay, if I may take, yeah. So you are moving this to the right by pi over 6. So if you now look at the new move shape, it is similar to this, right? Yeah, so you move it to the right. That's why there is a left part there being, brought down from origin rather than this. So being brought down like that. But then if you look at the most right curve, it got cut off, right? Because it used to be there and then it got cut off like that. All right. So this is indicating that, yeah, so if we expand a bit there, this would have been 2 pi plus pi over 6 right here. Okay, but this is 2 pi anyway. Now we can already answer yeah, the number of solutions, right? We just count the number of intersections. So gotta be careful. It's not these point P and Q, is actually that 1, 2, and 3, right? So that's 3. Okay. And then II. Now to 100 pi, we got to find a period first. So this is the first 2 pi. And if you notice, this part right here is like a periodic, is the beginning of the other part. So this part is the beginning. And now you have another beginning and another curve here. So it's going to repeat every 2 pi, right? So that means we're going to have every, we're going to have, let's see. So if we expand this line all down, we're going to get, we're not going to get this solution again, right? Because the line is already down, but we're going to cut this line around here. So if I draw that again here, this line is going to cut that line, which is this guy here, but on the next period. And it's going to go, it's also going to cut this line. So we got to be careful. There are only 3 solutions for the first period. Don't be tricked by that, guys. So 3 solution only for the first period, and for the remaining, how many there? 50 periods, because we have up until 100 pi, right? So 100 divided by 2, we get 50. So the next 49 periods, we only have 2 solutions. Yeah, gotta be careful because it only cuts the curved parts where it's below the x-axis. So that is 100 minus 2, which is 98. 98 plus 3, which is 101. Okay, so that would be my answer there. Now we, gotta be careful. It's now pi plus x. So the gradient is sort of like the other way around instead. So instead of this line, we have this kind of line on the left part. Yeah? Because when you flip the gradient from minus to plus, it's just going to be sort of like flip like that. And we can pretty much say that this is a mirror image. Because it's flipped, it has the same y-intercept. So we can pretty much say that this is a mirror image. It's like a reflection on the y-axis. So if we imagine we draw the curve to the left part, so we got that part right there. Okay, so okay, this is tricky because it's not gonna cut like that now. I think we're gonna have 2 solutions, guys, right? Yeah, because okay, we can try draw the whole graph again, but now to the left. So instead of that, and you have minus pi over 2 here. Further to the left, you have another period here. And for the sake of argument, here I'm just going to have to delete that. And also, I'm going to do that. So this is just the original 10. But then if you move to the right, it's going to be It's going to be like this. If you move to the right, yeah, so this x-axis will be moved like that, right? Wait, hang on, like this, sorry, yeah. And that means you're going to have to stretch this a little bit more just to complete with that part, right? Yeah, because you cut that part out. And that line is going to be cutting from there. So it's going to cut similarly to the other side here, this part. Definitely this one. Ooh, but it seems like it doesn't cut the other line, right? Because the line sort of like passed down. It doesn't have anything to do with this part. So it's actually further down where this part we don't have. So actually, this is the only point, I would say. Yeah, that's the only point. So actually, guys, it's 1 point. Yeah. I could be wrong about this, but I probably need to hurry up. The line with equation x equals a, shown in figure 3, is the asymptote of the curve with the smallest positive x coordinate. State the value of a. Okay, that's not bad. So it used to be at pi over 2. Now, because it has moved to the right by pi over 6, so that is just pi over 2 plus pi over 6, right? Equals, I can do the math there. So 6 plus 2 is 8 pi over 12, right? And that is just 2 pi over 3. So the equation, well, we just state the value of a. So a equals 2 pi over 3. That's it. The value of a, smallest, because it used to be pi over 2. Okay. C. The line with equation x equals b, also in figure 3, as an asymptote of the curve with the second smallest positive x coordinate. The line L meets x equals a, and at point P, and x equals b at point Q as shown. Find the midpoint of the line segment PQ. Okay, so we have that equation of the line. So the line equation L is pi minus x, right? Is the minus 1. So the point P and point Q intersect this line with x equals a and x equals b. So for P, because x equals a to pi over 3, that means y would have to be equal to, wait, hang on. Yeah, we have to find y anyway. So yeah, pi minus 2 pi over 3. That is just pi over 3 by my mental math. And point Q, x is equal to whatever. So we add 2 pi over 3 by another pi to get b. And that would be 5 pi over 3, right? Just adding more pi there. Y would be pi minus 5 pi over 3. So that will be minus 2 pi over 3, right? Yeah, that should be fine. So we find a midpoint. Just add them up, divide by 2. So midpoint is just adding the x up, divide by 2. Adding the y up, divide by 2 as well. And that would be my midpoint, answering here. So, okay. 7 pi over 3 here, divide by 2. So 7 pi over 4. This one gives me minus, yeah, that should be a negative. Yeah, okay, seems like. Negative pi over 3 on top, and then negative pi over 6 after you divide that by 2. So that would be the answer to that. Yeah, I think so. So we're done with that. And then we're gonna do the last question. We still have a lot of time. The curve C has equation all that. The point P, which lies on C, has coordinates 2 and -8. Show that an equation of tangent to C at point P is that. Okay. So tangent, we have to differentiate, right? Yep. So differentiate. So I'm just going to look at the question already here. Let me zoom in a bit more. Okay. So bringing 3 down, 3 multiply 3 in the denominator, I get 2x to the 2, right? This is differentiation. Minus x into 25 goes away. I just have 25. Now this is 56x to the -1, right? So -1 bringing down, this would become a positive, and then you would have 56x to the -2, right? Minus power subtracted by 1. And then that goes away, 0. And then we have to substitute gradient of tangent mt equals, substituting at p, x is 2, so 2 in. All right. So this is 8 minus 25 plus, so 2 to the -2 is 1/4. 56 times 1/4 is 614. Yeah. Yeah. And this is, so this is 11 minus 11, and then -3. So that would be the gradient. And then we do y equals y1 equals y minus y1 equals m times x minus x1s. Sorry, guys, a bit late. All right, so y1 being -8, so y minus -8 equals m being -3 times x, x1 being 2, right? So that's it. So y plus 8 equals -3x plus 6. So 3x plus y minus 2, moving 6 to the other side, I get 0 on the right side. Ooh, hang on. What? Okay. Ooh, okay. It's not the same. I'm in trouble. Okay. Oh, it is the same. What am I talking about? So y equals, oh, is not the same, is it? I must be blurred. Okay, so this must be a +2. Okay, you know what? I'm just going to delete all this. And then say that y equals -3x minus 2. Yeah, because that's just right. And then question B, and the last one. Point Q also lies on C, given that the tangent to C at Q is parallel to the tangent to C at P. Parallel, so m of tangent m equals the same. So because parallel, we can say that the gradient is also -3. And then because we need to know where point Q is, we can do that because we know the gradient is -3. So you can equate this -3 to the derivative function to find where is the other x point. So I'm going to say that. And then we're going to solve this to find the x coordinate of Q, right? Let's see. Well, how about if okay, I'm going to simplify first, and then I get 2x squared minus 3 bringing to the other side, I get -22 plus 56x to the -2 equals 0. Now, if I multiply everything by x to the 2, right, I get 2x to the 4 minus 22x to the 2 plus 56 equals 0. And if we recognize this pattern, you can see that x to the 4 and x to the 2, and there's another constant term. The first term has the power double that of the second term, right? This is a quadratic, right? So you can let x squared be something else, but I will just go ahead and maybe and we need to show the exact coordinates. So I think we can factorize, right? I'm gonna just factorize. I'm a big fan of factorizing. So because I believe we can do that because these are exact coordinates, I hope. So, because we already know that one of them is the point P, right? Because they have the same gradient. So one of them should be x of 2. So x of 2, that means x squared must be 4. So one of them should be 4. Let's take that. So I put that to 4 and put this to 14. Should that work? It does work, right? So 14x squared, and then with the 8, so I get minus and minus. You can check that. So 14x squared and another minus 8x squared, adding up, you get minus 22. All right. So the P will, the solution to P, the solution of point P will be here. So we focus on this one, because if you solve this, you get x of 2. 2 only because we do not take x less than 0. So we get 2x to the 2 minus 14 equals 0. So x to the 2 is 7, right? X is only my square root 7 because we take only greater than 0. And that is the exact coordinate of Q. There you go. That's it. And I think I'm done. So, but I got about 14 minutes left. So I'm going to actually go check from the first question. Going to make use of the time I have. Oh, it's just not many pages, right? So yeah, integrating. So 4, 4, 8. I think this is fine. Unless I copied the question wrong. No, I didn't. This one, solve the inequality. So expanding all in. And then I brought that to the other side, brought this to the other side. I get all that, flipping the sign correctly. B, so completing the square, I added 9 because I know that the complete square would be the 9 on the last term. Yeah. And then I get that. Yeah, that's right. And then we find a solution to that. So that is, we need to use that. So we substitute that, and then we use the difference of square formula. Yeah, making that root 8 here rather than 8. So a plus b, this is a minus b. So solving that separately, I get all that. So that should also be fine. But then we need to solve for the solution of the quadratic. So one is less than, one is greater than. Okay, so one is less than, that is actually that shouldn't be on the second quadrant. It should be on the first still, because this is greater than 0, but that's fine. They're not going to look at your graph here. And then C, we need to merge the two solutions with an AND here. So it's less than that, and also less than 35/3, sorry. And we're just going to go up to that. This is greater than that, so it has to be that. So that's fine. All the signs correctly, yeah. I think I'm happy with that. Number 3. dy by dx, giving each term in simplest form. Yeah, bringing the half power down, I get 48. Subtracting by 1, I get minus a half. So that's fine. Solution to the equation. So differentiating that again, 6x here, that's right. Bringing that down, I get a minus 24. That is again, equate that to 0. Yeah, factorizing that out. Okay. And then because I know that there is only one solution, so we discard that solution there. And solving for that, I get 4 to the 2 over 5 using the law of index there. I get 2 to the 4 over 5. Yeah. Yeah, that's done. Number 4. On this, kx plus 2. Yeah, I'm happy with that. Everything. Yeah. So B, yeah, this one I managed to show as required. So B, hence find the value of K for which L is a tangent to C. Okay, so yeah, the tangent we differentiate, we got that and that. So, and then we equate the gradient. We found the gradient of ML, which has to be equal to K. So because it's tangent, so we equate like that. And that's just one of the equations. And here I played the, I used some trick here because I observed that this is also another equation you have to solve, right? So I just substitute K minus 3 by that. And then after I do that, I can simplify by a lot more, getting x equals to over 3, substituting it back here. 9 over 4, 9 over 2, 6 over 2 minus 3 over 2. Yeah, I'm happy with that, guys. Number 5, this is going to be quick. Yeah, factorizing all out, I get that. 0 doesn't have any solution in exponential there. And then solving separately here for y, we get y is minus 2 and y of 0. Okay, happy with that. Number 6. Show that angle AFB is that. So this is as required. And then AB, yeah, we need to find using the cosine rule. So that squared minus 2, that times that should be okay. I checked the calculator already, so I'm not going to check it again. And BCD, which is the arc length. So that is R times theta, R being 6.2. Theta is already given, so that should be okay. And then you're gonna find a perimeter here. And so 2 times the AB, which is this guy in there, and 14.105 is the arc length, and then you 2 times 6.4, which is the straight line AE. That should be fine. One decimal place, find the cross-sectional area now. It's 2 of the triangles and 1 of the sector. So triangle, I use sine rule. Sorry, just the formula when you know the angle and the sides. And this is it. So the angle is just that. We found it in earlier. And then add with that, which is the area of a sector there. Half theta r squared. Number 7. Yeah. So, okay. So, yeah, we found AB. We found A by just substituting x of 0. And it's the y-intercept there. And B substituting the x of 10. So you get 6. And then substituting, sorry, find AB distance. We use the Pythagoras there, the distance formula. So that is, yeah, 116. You can take 4 out as 2 because we need to do a surd form. And then it says L1 and L2 being perpendicular. L1 is already 2 over 5, so L2 should be minus 5 over 2. Yeah, plugging in the linear formula there, using B as one of the point. And then doing the linear form, we get that. Yeah, so I think this is fine. And then C, because L2 is perpendicular, so we find BC. And the x-intercept of line L2 should be at y equals 0. So I substitute that. I get 62/5 as the x value. Sub it in. The distance formula again, I get some not nice number, but that's fine. Because somehow when I multiply it again, using the exact number from the calculator, from 2 root 29, I somehow managed to get that nice number, right? So that hopefully should be fine. Number 8. This is just integration, right? So number 8, yeah. So expanding all out, I get 3x squared minus 7x minus 6. So that should be fine with the 2 outside. And then 2 multiplying back in, I have everything there. 13, this is to find c, so I sub 4 and 13 in. 13 is a y. 4 is all the x's. Should be fine. I think I checked this twice in the calculator, so c should be right. And plugging all back in, I get the equation of fx. Now b, factorizing, yeah. So because I just expand the repeated root, and then I check the term. So the p and the q should give you 45 because I have 45 here. So q is 5 already because this is 9. And then using that known q, you can find p, right? So I check the x term, I think. So pqx and the minus 6qx here equals the minus 12x up there. X cancels out, and then we get q with the 6 being minus 30 here. Q is 5, so 5p here. So 18/5 should be right. And then due to the transformation in C, we're going to have to imagine if we plot the actual graph of fx, we're going to get 3 there, so we shrink by 2. And the other side, we would get minus 25/18, so we shrink by 2, we get that. Y-intercept remain the same, which is 49, already shown that. Number 9, this is tricky. So solution of the first question is 3 because there are 3 intersections. And then the second one, well, the first period is 3, but the other 49 periods only have 2. So I did that. So that's 98 plus 3. That should be right. And on the left part here, already shown to you, it only cuts 1 point. So I'm going to put 1 there. Yeah. So now we have to solve for x. It's just the smallest point of the asymptote here. So that should be fine because we do pi over 2 plus pi over 6. So that is still 8/12, 2/3. Yeah, I'm happy with that. And then you're going to have to solve for part C, right? X equals 2 pi over 3 on the line. And the line equation is pi minus x. So I get pi over 3 from that. X being 5 pi 3, I get that. So that's fine. 2 pi over 3 plus 5 pi over 6. And this is to find the midpoint between the PQ section. I'm okay with that too. Number 10, last one. So differentiating the first one. Yeah, I'm happy with all that. That become -2 and this is a plus, yeah. So the gradient of the tangent to C at P is 2, right? So we substitute 2 in. And then I managed to get this, right? I think. So I'm not going to double check that. And now another point at Q with the tangent being parallel to the other point. So gradient has to be the same. Yeah, this one seems fine. So I'm going to stop the clock now, guys, and mark the paper. So I just took that long. Now I'm going to mark the paper. Okay, marking the paper, right? So looking from question 1. Question 1, where is it? Here. Okay, so yeah, that's right. Looking at the answer already. This is right. X less than 3 minus root 8. Hang on. X less than 3 minus root 8 or x greater than 3 plus root 8. And this is the C part here. Yeah, that's fine. Number 3. Number 3a should get that. That's right. 2 to the 4 over 5. That's right. Number 4. Yeah, this is as required. K was minus 3 over 2 down there. So everything is fine, guys. Number 5. Got that for the first part. 0 and minus 2. Hooray. Number 6. Yeah, as required. And then perimeter. 32.3, 60.4. Number 7. We have 2 root 29 here for A. And that is for the linear equation. And this one is nice. I got it. Number 8. 2x to the 3 minus blah, blah, blah. 49. Yeah, B is, hang on. Oh, yeah, turning point, yeah. That, and is that actually, so let me check. So this is this, hang on. I could be wrong for this one. Hang on. So let's have a look at B. So Q is 5. Oh no, P is 2. Okay, P is 2. Maybe you shouldn't rely on this method now, right? It's not reliable already. Okay, hang on. I didn't see this coming. Yeah, I think I lost 1 for that. Never get full marks, right, guys? And yeah, let's see. Do I get a follow through here? Because I just divide my answer earlier by 2, right? Wait, hang on. Yeah, because this would have been Q over P, right? Yeah. Yeah. So I think I got that mark. X intercept at that, no, pass through, not stop at. Allow if there are other intercepts, do not allow if mark. Okay. So yeah, lost another mark there. Darn it. Okay, that's fine. 2 marks for a weird method. Okay, I mean, long division is probably okay. Okay, this one. Ooh, wait. Oh no, what happens there? So does it cut the other point? All right. So be it. And I got A right, and I got the other one right, I hope. No? Why is that? Wait, what? I did a wrong mental math there? This is a bad paper, guys. To me, I mean. Yeah, this is 706. Wait, 703? Oh no, how did I get 4? That was stupid. I didn't check for that. -1. Yeah, sorry guys. Yeah, I think I got that one. So that was fine. And then yeah, row 7 only. So I lost 3 marks, guys. So that means I got 72 out of 75. I guess that should be still 100% UMS, I guess, I'm guessing. Or maybe close, depending on how well other people did it. I think overall this paper was a bit tough. Yeah, I spent too long checking while I didn't see some of my mistakes. But there you go. Unseen paper, no cuts, no edits during the time. Don't forget, guys, keep studying. See ya.